Mm-hmm. Huh? Yeah, just go quickly. Yeah, just hurry. All right, you guys. So we're starting off with this blank unit circle. Just has nothing. You don't have a copy of this at your desk or whatever, but I'm just referring to it really quickly because it ties into what the direction we're going in. We are still working with Trig content. That's still sticking around for a bit. But I just wanted to recap a few weeks ago how we discovered in the unit circle that there are many embedded right triangles inside this unit circle. And then at the edges of this unit circle, you have these points that you can travel to, so to speak. So if you started at the origin, you would move to the right x distance, up y distance to arrive to the point, and you guys had values over here. We also learned that the radius of a unit circle always had a hypotenuse of, for every single one of those right triangles had a length of 1. So if I implemented the Pythagorean theorem of a squared plus b squared equals c squared, notice that your a value would be the x, the b value would be the y, and then your c value would be the 1. So that's why you end up with x squared plus y squared equals 1. Okay? So how does this tie into what we're doing? So my question to you is this. When you guys had the unit circle before you, and I asked you, for instance, to find the sine of 60 degrees, sin of 60 degrees. When you look at this unit circle, what is the sine of 60 degrees? What is the sine of 60 degrees? What does sine mean? Okay, about half of you have to take a midterm in about 2 weeks. You need to remember the stuff you learned. What does sine mean? If I ask you what is the cosine of 60, what's the cosine of 60? Okay. For the sake of time, okay? Cosine and sine means x and y. If I asked you to find cosine of 60, all you would tell me it's a half. If I said find the sine of 60, you would tell me square root of 3 over 2. Okay? If I asked you for tangent of 60, tangent was what? What did y'all do for tangent? Y over x. Good. So you would take the y value divided by the x value. Okay? So if cosine is x and sine is y, what you guys are going to do is instead of x squared plus y squared equals 1, you're going to start visualizing cosine squared plus sine squared equals 1. Okay? This is what we are going to call the Pythagorean identity. So this is what this section is all about. Transitioning from this to this. Okay? So if you have your pack in front of you, please know that this packet is very thick and we're not completing this all in one sitting. It is a packet for 3 days and it has homework for 3 days. That's why it's so thick. So please don't lose it because you will have to print it again for yourself, okay? So day 1 here is going to be our first day. So if you want to put above notes today's date, today is November 30th, and this is where we are going to start for day 1. So tangent theta, we know it as, Willow told us here, y over x. But I want y'all to transition from that formula to sine of theta over cosine of theta. Okay? Because we know that y means sine and x means cosine. Okay? Now just in case you're like, I don't remember learning the y and the x's and stuff like that, this was the formula sheet that you guys had for your last test before the one we just took, and that's the stuff that I'm talking about right here. Okay? Sine was y, cosine was x, tangent was y over x, and those are your reciprocals. So we are moving away from these formulas and rewriting them in trig format. Okay? So that's what I'm trying to draw your attention to. So instead of cotangent being x over y, we are going to write it as cosine of theta over the sine of theta. Okay. Cosine of theta over the sine of theta. Okay. So we have tangent, cotangent. I'm going to write out the word for this one because I know students tend to forget how to pronounce this one. CSC is cosecant. Cosecant is the reciprocal of sine. You guys knew it as 1 over y when you guys did the unit circle, but I want you to transition now over to 1 over sine of theta. Likewise, secant was 1 over x. I want you to transition to 1 over cosine theta. Now, rest assured, I do not expect you to memorize or need you to memorize all of these, but the more homework you end up doing in practice, you're going to notice that you end up memorizing it regardless, okay? But you're not obligated to, and you will be given a formula sheet when you guys are assessed, so you don't have to have that pressure of memorization, okay? So this is your notes. What we do on this first page is teaching you how to manipulate these formulas. Please, again, don't think that any of this is required memorization at all. It is not, okay? Okay, so here are four formulas that I've just given you for sine, cotangent, cosecant, and secant. Here's the pronunciation for these. And I want to remind you guys that anytime you guys see 1 over, that's literally means you're taking the reciprocal of something, okay? So whenever you see 1 over, it's a reciprocal, all right? So those are called the reciprocal identities. So let's get started here. So the Pythagorean identity that we're going to work with is going to be, the first one is the one that I showed you in this green blurb. And we're going to write it out here. Cosine squared theta plus sine squared theta equals to 1. So I'm going to box it in because this is the first of 3 Pythagorean identities that I'm going to introduce you to. We have 2 others to be introduced to. Okay. All right. Now, when you guys are writing your trig functions, please make sure to always put a theta or a number. For this section, it's going to just be a theta every single time. Don't ever write it like cosine squared and that's it. You can't just have a blank space after the words cosine and sine. Okay. All right. So here we go. They want us to solve the Pythagorean identity above for cosine squared theta. So I have my Pythagorean identity, and when you are solving for a particular term, what they're asking you to do is to isolate that particular term. So in this case, this highlighted cosine squared is what they're trying to get on one side of the equal sign all by itself. So if I have my equal sign represented by my pencil, right now, cosine squared is not isolated. It hasn't been solved for. So what do I need to do to both sides? Subtract sine squared. Good. So I'm going to move sine squared by subtracting sine squared on both sides. And now the cosine squared theta is all alone on one side. So what you are going to see throughout this first page is that Pythagorean identity formulas are able to be manipulated. You can manipulate them as much as you want. It doesn't have to stay in this format. Okay, so would you now take that same formula, and I want you to solve for sine squared theta. Do that one on your own. Okay. All right, so Judy, what did you do on this one to isolate? Good. So she subtracted cosine squared theta on both sides and isolated your sine squared theta. So even though the trig identity has now changed in format, it's still the same formula 3 times over, okay? So what I want you guys to notice is if you flip your page over to the other side, okay, there's going to be a chart, okay? And what you are going to notice in this chart is that this row right here, okay, was, let me see if I can bring this lower enough. Okay, so this right here that we squared off in your Pythagorean identity, that is this formula right here. Okay, that's that formula right there. And then when I asked you to solve for cosine squared and I asked you to solve for sine squared, the answers you got were these answers right here. These are the manipulated ones. Okay, so this is your Pythagorean identity. These are 2 samples of you manipulating this formula. Does that make sense? Are you with me so far? Okay, so going back to the front page again, let's find second Pythagorean identity. So we're going to do what it says here in the instructions. They said take the Pythagorean identity and now divide everything by cosine squared. So they already wrote it out for us. So I'm going to divide by cosine squared theta, divide by cosine squared theta. Make sure you put your theta. Divide by cosine squared theta. Okay, so I'm just following instructions. And when you do this to your original Pythagorean identity, it is going to generate the second Pythagorean identity that I want you guys to be accustomed to. So I'm going to draw an arrow here because we're about to square off the answer to this next boxed Pythagorean identity. So when you divide 2 terms that are identical, you always get a 1. 10 divided by 10 is 1. 5 divided by 5 is 1. Cosine squared divided by cosine squared is 1. So that 1 comes from this. Then there's a plus sign. Sine squared divided by cosine squared. So here's something new for y'all. So sine squared over cosine squared is going to require you to go back upstairs. And there's some formulas I gave you. And notice that sine over cosine was the same thing as tangent, correct? So the only difference is down here, we didn't have a square. So what I'm going to do is if sine over cosine is tan, sine squared over cosine squared is going to be tangent squared. You are allowed to do that to your formulas. So in that same manner, if you go back upstairs and look for 1 over cosine, so glance back to the top with me. Secant, very good. Now since this one was squared, we just need to add on that little 2. Okay, so if you don't know where that was found, if you go back upstairs, the 1 over cosine is secant. So if this one is squared, this one has to be squared. So this class is going to be your second Pythagorean identity. Okay. And just like your previous examples, this Pythagorean identity can also be manipulated for whatever it is that you're looking for. Okay. So in this case, they want us to use this Pythagorean identity and manipulate it by solving it for tangent squared theta. So I'm going to highlight this one. And I know at this point, you're probably saying, okay, this is getting redundant. Aren't we just subtracting every single time? So if you're having that discussion, that's the whole intent. I want you guys to notice that with these Pythagorean identities, since everything is adding, when you're moving things, you end up subtracting more often than not. So what do I need to do to both sides to isolate tan squared? Very good. -1, subtract 1, I heard. Both are correct. And so here is the new format. Okay. Popular question is asked, when do I know when to manipulate it and do that kind of stuff? You'll know as we move on into the lessons. By day 2 or day 3, you'll know a little bit better. You don't have to worry about that too much in day 1, okay, which is today. All right, so I want you guys to discover the third last Pythagorean identity by following the instructions here. take the Pythagorean identity that we started out with, and instead of dividing by cosine squared, I want y'all to divide by sine squared. So do that, find the new boxed one, and then I want you to solve for cotangent squared. So I'm going to give you about 2 minutes to do that. So go ahead and do that. Okay, I'm gonna show you the answer soon. If you're not ready, don't look up. Okay. If you have any questions, please ask. So there are 3 Pythagorean identities, the 3 boxed in formulas that you have. And so the whole entire purpose of this front page is getting you guys to understand that these can be manipulated, okay? So again, you don't have to flip over. I'll just show you here on the screen. Again, that's the whole meaning of this box whenever you guys go over. This here are the second 2 boxed in formulas that we just found, and these are the manipulated formulas for this one, manipulated formulas for this one, and there are others, but they're just providing you with some samples. Okay, all right, so any questions so far? We're okay. We're gonna use what we're learning right now to do some problems in a second. All right, here's some other identities. You have sine is the reciprocal of cosecant. You can rewrite them in reversed format. Again, all of these are going to be in the table for you, so no need to memorize these, okay? I just need you guys remembering that they're reciprocals of one another. And the way that I've told you since day 1, since we've been doing unit circle, the way I remembered them, unless you can figure out a way for yourself, the reciprocals are always going to start with an S and a C, okay? They always start S's and C's. So if you're looking for the reciprocal of sine, it has to start with a C. If you're looking for the reciprocal of cosine, which starts with a C, the word has to start with an S. It's always C and S. And tangent, well, it's obvious. This one has a T and this one has a T. So keep that in mind, and it helps you kind of remember the names, okay? So cosecant and secant go together, sine and cosecant go together, tangent and cotangent go together. So, sure, sweetie. Okay. So, if you are done with this page, flip over. You're going to notice in the next page and the following, there is examples 1, 2, and 3. We're going to only do examples 1 and 3. 2, you guys already know how to do, okay? So, starting with example number 1, we have 4 questions, a total of 8 questions we got to go through, okay? These go faster when you participate. So if you guys just sit there, it won't go by fast and you're going to fall asleep. So try and participate, and let me show you guys how these are done, okay? So keep an open mind because this is pretty new stuff, okay? But it's actually pretty simple, all right? You just have to get accustomed to not using very many numbers, but letters, okay? All right, so here's the rule that I need you guys to do. I'm going to have you guys look at given expressions, and I'm going to need you guys to simplify it. And I want you to simplify them in a single term. In other words, when you are done, your final answer is going to have only one term left. Or it will only have a constant left, which means it's a number term, a numerical value, I should say. Okay? So your final answer is either going to be a number or just one term. Now here's the rules though. When you guys are simplifying these expressions, whenever you see sine or cosine, I want you to just leave it as sine and cosine. You are going to be tempted to do this. You're going to see a sine and you're going to want to write it as 1 over cosecant. Don't. If you see a cosine, you're going to want to write it as 1 over secant. Don't. You will only do that 1% of the time, if ever. It's so infrequent that I tell students just don't ever do it. Okay? It's very, very infrequent. So everything else I do need you to change. So here's what I mean by that. Let's do A. This is a tangent, tan theta. Since it's not a sine or a cosine, that means I need to rewrite it. So I'm going to go upstairs and I'm going to go find tangent theta. I'm going to notice that there are two options I get to choose from tangent theta. Most of the time, it's going to be this one. Okay? Most of the time, it's going to be this one. Between cotangent thetas, most of the time, it's going to be this one. The ones with 1 overs, 1 over, 1 over, 1 over, 1 over, 1 over, 1 over, those are hardly ever used. So when you guys are looking at this chart, I want you guys looking at these and the Pythagorean identities. That's where you look for most of the time, okay? So tangent is the same thing as sine over cosine, okay? So I'm going to come down here and I'm going to say tangent is sine over cosine. I am substituting tangent with its other formula, sine over cosine. Right next to tangent, I see a cosine, and Hanlon told me that when I see cosine, leave it alone. So just write it out. If I see cosine or if I see sine, just write it down. So what's going to happen here is because we have multiplication happening and this numerator and this denominator are identical, I am able to reduce because cosine divided by cosine is 1. So sine theta times 1 is just sine theta, and I'm done because I arrived to a single term answer. And my problem is finished. Okay? So maybe you're like, okay, all right, this seems kind of okay. I'm not sure about this yet. So let me walk you through another one. Okay? Are there any questions on this first one though, first? Silence, we're good? Okay, let's walk it through again. The numerator is 1 minus cosine squared. Go upstairs and find 1 minus cosine squared up here. And if you find it, tell me what it is. All right, so right over here, Sammy found 1 minus cosine squared is equal to, or the same as, sine squared. So I'm going to come over here and I'm going to replace 1 minus cosine squared with sine squared. Why? Because I'm trying to get a single term. So if I have two terms here, 1 minus cosine squared, now I converted it into one term. That's a lot better. Over this cosine squared, Hanlon said do not change. So I'm going to bring it over. Cosine squared. Now, doesn't sine over cosine ring a bell? Very good. Sine over cosine is this one right over here. She said tangent, but because both of these are squareds, what are you guys going to tell me? Tangent squared. And that's a single term, so I stop. This is not a single term because you have two of them. Break it down to 1. Okay. All right, so 1 minus cosine squared was replaced with sine squared. This just came over. Sine over cosine is tangent. Okay, let's go to part C. Do I change this one?
No.
No. Good. Cosine theta, leave it alone. Let's see, I'm going to ask, who is over here? Madison. Madison, what is cosecant theta going to be rewritten as? Look at the chart upstairs. Go find cosecant theta. And very good. So cosecant theta is going to be 1 over sine theta. Okay. So notice how I wrote this, okay? Cosine times 1 over sine. So you probably are saying, why is she writing it so low? Okay. A lot of students do this. They do cosine theta and then they go times 1 over sine theta. When you write it like that, it's very misleading because it looks like your cosine is multiplying with your sine, and that's incorrect. So if you have a single term multiplying by a fraction, that single term actually has like a 1 underneath it. So it may look like I am like sinking sand when I write my fraction like that, but it's reminding myself that when I'm multiplying the cosine times the 1, which gives me cosine theta. And then I'm taking the invisible 1 that's underneath my cosine and I'm multiplying that by sine, and that gives me sine theta. Okay, so be careful when you're multiplying. Okay, numerators multiply with numerators, denominators with denominators. So here there was no, canceling that could happen. So we just straight up multiply. Do we stop here? What is that equal to? Good. Cotangent theta. So go back upstairs, find the cosine over sine. And there was what Maria found. Cotangent. Are we good? All right. We're about to be halfway, you guys. All right, sine theta. Do we change that? No. Nope. So we put sine theta. Secant theta, let's see. Let me ask Emma. What is secant theta going to be? SEC theta. Secant theta.
1 over cosine.
Good. So 1 over cosine theta. So I'm doing that little sinking sand thing because I'm trying to remind myself that that sign has a little 1 underneath. All right. Everybody good with that so far? All right. Tangent theta. What's tangent theta going to be? Sine over cosine. Okay. So as long as you just kind of keep it all organized with each other, you'll start seeing things clean up. Okay. The whole goal in these type of problems is that things constantly start canceling out like crazy. And if it's not canceling out, something is wrong with what you substituted. All right. So again, we recognize that that sine theta has an invisible 1. So what does this times this give us? What does that be? Devin, you tell me. Sine over cosine. So sine theta over cosine theta is this part. And it so happens that we also have a sine theta over cosine theta at the bottom. So what is this quantity equal? What's sine theta over cosine theta divided by sine theta over cosine? It would be 1. Everything just kind of cancels out, right?
It can be a number value.
Yeah, so up here, it can be either a term or a constant. Yeah, good question. Okay. All righty. This part here, don't worry about it. You guys have done enough of stacked fractions, so you'll get the practice here on example 3. So here are your last 4. Okay. All right, so complex fractions are another word for stacked fractions, okay? And you guys have done stacked fractions a lot because when you guys did the unit circle stuff, if you did tangent, you had to do y divided by x, and y'all were dividing fractions all the time. What you guys did is you did the keep, change, flip approach, which technically is not really a true math methodology. It's just a quick way to help you remember a technique. But what you guys are actually doing is you're multiplying by the reciprocal in order to simplify dividing fractions, okay? So that's what you're doing. So let us see how you can use this technique to help you simplify these expressions, okay? So you're going to do the same thing what you've been doing. Nothing is changing in your approach. It's just a different algebraic cleaning up method. So I'm going to call out on another person. Let us call out on, let's see, Kayliana. Tell me what cosecant theta is. Awesome. 1 over sine theta. And then let's see, Shaylee, what about cotangent theta? Look for COT.
Oh, okay. It's cosine theta over sine theta.
Good job. So cosine theta over sine theta. Alrighty. So if we have this divided by this, notice you have a very, very complex fraction or stacked fraction. And I'm making this line very, very dark for a reason. Okay. So what you're going to do is take this top fraction that goes above this very darkened division line, which represents this one right here. You are going to keep this here, the division bar, you're going to change to multiplication. And this one right here is you're going to flip by exchanging your numerator and your denominator. That's the keep, change, flip thing. So how do we write that out? So we keep the top fraction, 1 over sine theta. We change our division to a multiplication. And then I interchange my numerator and denominator. And more often than not, when you do this, you are going to be able to clean up mathematically through cancellation. Because in this case, my numerator and my denominator values are identical and they are multiplying. As long as there's multiplication, identical terms, and one is in the numerator and one is in the denominator, you're allowed to do this. But it has to be multiplication, okay? So you are left with 1 over cosine theta. And so let's see, Ian, what is 1 over cosine theta in our table? Good. So on this one, it will be secant theta, but you did visualize the correct one. Very good. Okay. Are we surviving? All right, let's go on to the next one. All right, 1 minus cosine squared. Let's see, Eddie, go find 1 minus cosine squared for us. What is that equal to upstairs? Sounds good to me. So sine squared theta is my 1 minus cosine squared theta. So I'm going to put a darkened division sign here to help me remember that that's my keep, change, and then my flip situation. Let's see, tangent squared. Tangent squared, let's see, Willow. Tangent squared, how would we rewrite that? Awesome. So everything's broken down now. And once everything has been broken down, we should be ready to keep, change, flip, or multiply by our reciprocal. So we will keep sine squared from Eddie. We will multiply, and then we're going to flip Willow's answer and see if anything cleans up. And thankfully it does, because there's an invisible 1 underneath this. So we have a numerator and a denominator. So our final answer is cosine squared. Okay. So notice the difference. If you cancel here, you had a cosine squared over 1, so it's just cosine squared. But over here, this one canceled like this, and the 1 was on top. So 1 over cosine is secant. So make sure you guys see the difference between the two. Okay? All right. Here is a trick. We're almost there. Here's a trick that I want you guys to observe. Well, not even a trick, a property. So write this down to all right, this reciprocals property that I want you guys to recognize. If you multiply reciprocal trig functions, they will always equal 1. So what I mean by that is this. If you have a sine function and you multiply it by the reciprocal, which one's the reciprocal of sine? What does it start with?
C.
It starts with the C, right? So that one's the CSC one, cosecant. If you take sine and you multiply it with cosecant, the answer is going to be 1. Another one, if you have cosine theta and you multiply it by which one? Very good. The secant one, you will also get 1. And lastly, if you have tangent theta and you multiply it by what? COT, cotangent theta, you will equal 1. I want you guys to keep these in mind, because if you do, it will cut down on a lot of work. Okay? So look at the one we're getting ready to do, right? What most students start doing if they don't remember these tricks is they start breaking down all of them and creates more work. It doesn't mean that it's wrong at all. You can totally break it up, it just takes you longer. But if you notice right off the bat, when you look at a problem that two reciprocal functions are side by side one another, what can you replace that highlighted term with? A 1. Very good. So I can take that highlighted thing and say, oh, well, that's just a 1 over a tangent. And what is 1 over tangent? Cotangent, and you're done. Okay? Could you have done it the other way, breaking everything up and multiplying by keep, change, flip, and all that? Yes, you would have ended up with the same answer. It just would have taken you a lot longer. So remember these pairs, and they always become a 1. You will cut down on a lot of work. Okay? All right, last problem. Ready? All right, you guys are doing awesome. You're very quiet, but you're doing good. Okay, the numerator sign, we do not touch it, so we'll just leave it. And let's see, let's see who's over there. Nicholas, how can we rewrite cosecant theta?
1 over sine theta.
Okay, 1 over sine theta. So here we go, we have another stack fraction, oof. So there's my sine divided by 1 over sine. So when I have more than one division bar, I have a stack fraction. So I'm going to keep, change, flip. So I keep the sine theta. We never change it. We change it to multiplication, and then we are going to flip. Okay. All right. So can we cancel? Okay. Why can't we cancel?
They're not like numerator.
Very good. We're not numerator, denominator. Of the 3 conditions, it only meets 2. Are they the same? Yes. Is it over multiplication? Yes. Is one in the numerator and one in the denominator? No. It fails in that sense. So what is sine theta times sine theta? Very good. Squared, good. Sine squared theta. And we are done. So the knowledge you have just attained, you will challenge yourself. When you flip over at the top, you'll see the homework for day 1. There are 8 problems. Now here's what I want you guys to understand. I am not collecting these for a grade, okay? But I need you to complete these because by day 3, I'm thinking, when you guys walk in, so that will be, what's today? Wednesday, Friday, Tuesday next week. I will say, okay, you have 10 minutes. Here are 5 problems. Work them out really quick and turn them in to me, okay? But you won't be able to do that if you haven't practiced, okay? So please practice. I have the answer keys here at my desk. If you want to look at it, I'm going to put them up on Canvas as well. Work these out. The remaining time is your time. It is I don't know what time it is. Can't see without my glasses. 2:34. You have a little under half an hour left, okay? If you have any questions, let me know. And that's it. Thank you, my dears.